First, we will discuss about the word defer. According to the dictionary, it means to put off an action to a later time or postpone. Now, deferring a payment means you are delaying it without violating any agreement or any rule. Next, a deferred annuity is a financial transaction where annuity payments are delayed until a certain period of time has elapsed. I think you will best understand the concept of deferred annuity through this illustration. And as you can see, we have two stages, accumulation stage and then the payment stage. In this first stage, you make a single payment at the start, which earns an interest and matures in end of period of deferral, and the maturity value will now become your principal amount for your payment stage. In your payment stage, you have a regular payment based on your principal amount, which also earns an interest, and it will mature at the end of annuity. The difference is in accumulation stage, you only have single payment, but in payment stage, you have a regular payment to be made.
Now, let us discuss about deferred ordinary simple annuity. On the day of their granddaughter's birth, Mr. and Mrs. Quarterly deposited 3,000 pesos into a trust fund for her future education. The fund earned 7% compounded monthly. When she turned 18, they wanted to make payments at the end of every quarter for 5 years. If the income annuity can earn 3% compound quarterly, what is the amount of each annuity payment to the granddaughter? As I have said, it has quarterly payments at the end with a quarterly interest rate. So it is ordinary annuity from the word at the end with a quarterly interest rate. So it is also a simple annuity because interval payment, which is a quarterly payment, is equivalent to the interest interval, which is quarterly interest rate. Next, since it is a deferred annuity, it has a single payment at the start, so at birth, which earns 7% compounded monthly, and then at the age of 18, it is now an end of period of deferral, and then start of payment stage, it has 3%. The maturity value of that single payment, 3,000, will now be their principal amount for annuity, which earns 3% compounded quarterly, and the deferred annuity end of annuity will be 23 years. So because the deferred annuity is good only for 5 years, so we are now finding what will be her quarterly payment. So here we will first find the maturity value of the single payment, 3,000 pesos, which earns 7% compounded monthly for 18 years. So given interest rate is 0.07 divided by 12, because conversion period is monthly, it is now equivalent to 0.005833, and then our N is 18 years times 12, which is 216. So our principal payment is 3,000. We are now looking for the future value.
Here are the given. J equals 0.07 divided by 12 equals 0.005833. It is a non-terminating decimal, so I approximate this in this value. N equals 18 years times 12, it will give you 216. P P equals 3,000 and future value is missing. So for future value, formula is A or FV equals P quantity 1 plus J raised to N. Replace P by 3,000, J by 0.005833, and N by 216. And the sum inside the parenthesis is 1.005833, raised it by 216 is 3.512287895. Multiply it by 3,000, it will give you 10,536.86368. Therefore, your 3,000 having 7% compounded monthly for 18 years will give you 10,536.86368. Okay, your next goal is to solve for the regular payment. And here are the given. J equals 0.03 divided by 4 equals 0.0075. Remember that we are now in the payment stage. N equals 5 years times 4 equals 20. And our present value is 10,536.86368. And from this formula of present value, we will derive, since we are looking for the regular payment, we need to solve for R. And to solve for that, we divide both sides by bracket 1 minus quantity 1 plus J raised to negative N over J. And replacing P by 10,536.86368 over 1 minus 1 plus 0.075 raised to negative 20 over 0.0075. That will give you 1 plus 0.0075 raised to negative 20 is 0.86, 11, 89, 85, 23. And numbers in the denominator in simplified format is 18.5081,969. And 10,536.86368 divided by 18.5081,969 will give you 569.3134034. Okay, your 569.3134034 will be your quarterly payment beginning at the age of 18 until the age of 23. Therefore, the grand daughter will receive 569.3134034 at the end of every quarter for 5 years starting when she turns 18.
Now, let us discuss about deferred ordinary general annuity. Let us take this example. Elias is 33 years old and just received an inheritance from his parents' estate. He wants to invest an amount of money today such that he can receive 5,000 at the end of every month for 15 years when he retires at age 65. If he can earn 9% compounded annually until age 65 and then 5% compound annually when the fund is paying out, how much money must he invest today? So, it is a deferred annuity that has monthly payments at the end with an annual interest rate. So, it is ordinary annuity from the word at the end of every payment interval, and it is a general annuity because payment interval it's not the same with interest interval. So I think you will best understand this problem by this illustration. So at the age of 33, we are looking for the present value, the money that he must invest today in order for him to receive 5,000 pesos monthly upon his retirement at the age of 65 for 15 years. So our end of annuity is the age of 80. So he wants to receive 5,000 monthly, having 5% compounded annually. So here we have two missing variable: the present value, which is the money that he must invest at the age of 33, and then the future value at the age of 65. Since it is a general annuity, we need to go through along this process. We need to match the interest period to the payment interval, and to find that, we need to find the monthly rate that is equivalent to 5% compounded annually. So for the first step, using the formula A equals P quantity 1 plus J raised to M, we need to find the value of 1 peso invested at 5% compounded annually after 1 year. So our J is equivalent to I, which is the interest rate, over M, which is the number of conversion period. So 0.05 came from 5% compounded annually. So 0.05 over 1, which is the conversion period, which is annually. And then that is equivalent to 0.05. So remember that M is equivalent to 1, which is the interest period per year. So plug these values into our given formula. Our P is equivalent to 1 peso. So A equals 1, quantity 1 plus 0.05 raised to positive 1. And then simplifying the number inside the parentheses, 1 plus 0.05 is 1.05. And raising to 1, it is still 1.05. Multiply it by 1, it is 1.05. Okay, now we will be focusing on payment interval, which is end of every month. So for the second step, we let equivalent 1 over 12 year rate, since we are the payment interval is monthly. 1 over 12 year rate be J percent, finding the value of 1 peso invest J percent per year after 1 year. So here are the given. P equals 1 peso, and then M equals 12 from the word monthly, which is the number of times interest is compounded per year. So we will be using again the formula A equals P quantity 1 plus J raised to M, and then substituting all the given values. So A equals 1 quantity 1 plus J raised to 12. Next, A equals quantity 1 plus J raised to 12. Multiplied by 1, it is 1 plus J raised to 12. So here we are looking for the value of J. So for the third step, we know that we need to use the value that we got from the first step, which is A equals 1.05. Also, the value that we got from the second step, which is A equals 1 plus J raised to 12. And then, since as you can see, as you can notice, they are both the values of A. So by transitive property of equality, these two amounts must be equal. Then A plus J raised to 12 is equivalent to 1.05. And raising both sides by 1 over 12, it is 1 plus J raised to 12 raised to multiplied by 1 over 12 equals 1.05 raised to 1 over 12. And then 12 multiplied by 1 over 12 is 1, so it is only 1 plus j equals raising a number to 1 over 12 will results to 12th root of that number. So 12th root of 1.05. And then by the use of addition property of equality, so adding negative 1 to both sides, so it will be j equals 12th root of 1.05 minus 1. And then for the final answer, simplifying 12th root of 1.05 and get the difference of the two numbers, we got the value of j, which is 0.00407412378. Actually, you need to use the whole decimal numbers, so to come up with an accurate and complete amount. For the fourth step, we need to apply this formula, which is P equals R bracket 1 minus quantity 1 plus j raised to negative m over j. Here are the given. So you want to have a regular payment, which is 5,000 for 15 years actually. And then your j, that the value that we got from the third step, which is 0.00407412378. And then for n, it is equivalent to m multiplied by t, which is our m is 12 for the monthly rate, and then 15 for 15 years. And that is equivalent to 180. So let us plug these values into our given formula. So P equals 5,000 bracket 1 minus quantity 1 plus 0.00407412378 raised to negative 180, which is our n, over 0.00407412378. So first, we need to simplify the number inside the parentheses. So the sum of that number is 1.00407412378, and then raising that number to negative 180, it is 0.4810170981, and then getting the difference of one line of the number in the numerator and then divide it by 0.00407412378, then it is 127.385158. Multiplying by 5,000, it is 636,925.79 centavos.
Here are the given. J equals 0.09 from 9%, N equals 32 from the difference between 65 and 33, and your future value is 636,925.79. P, which is the present value, it is missing. So let us use this formula. Replace A by 636,925.79 and J by 0.09 and N by 32. And if you aim to solve for P, you need to divide both sides by quantity 1 plus 0.09 raised to 32, and that is 636,925.79 divided by this number. So 1 plus 0.09 raised to 32 is 15.76332879, and 636,925.79 divided by this number will give you 40,405.53861. Initially, you need to have 40,405. Therefore, Elias needs to have 40,405.53861 today to sustain 180 withdrawals of 5,000 monthly for 15 years.